welcome to Inferential Statistics for Researchers. In this video, I'll be discussing hypothesis test. Hypothesis test is a statistical test which helps to decide whether to reject a hypothesis or not. If the non-hypothesis is rejected, we say the test is significant. Hence, the test of hypothesis are also called the test of significance. What are the ingredients of statistical test? To successfully carry out any statistical test, the knowledge of the following is required. 1. Statistical hypothesis. That is, you should be able to distinguish between non-hypothesis and alternative hypothesis. 2. Level of significance. 3. Decision rule. To start with, what is a statistical hypothesis? A statistical hypothesis is an assumption, guess, or proposition made about a population for the purpose of making statistical decisions about the population. These assumptions or guess may not necessarily be a true reflection of the population involved. That is, this assumption may not be true of the population. For example, a guess can be made about the mean age of students in a university. Such an assumption is what we call a statistical hypothesis, or simply a hypothesis. Types of statistical hypothesis. There are two types of statistical hypothesis. These are, we have the non-hypothesis, then we have alternative hypothesis. Hypothesis is a testable assumption or proposition about a population under study. This is the hypothesis which a researcher intends to find evidence against through testing. The non-hypothesis is usually denoted with H0. For example, H0 could be mean age is equals to 25. That is, the mean age of a group of students is equal to 25, where mu surface age is the population mean age of the students. What is alternative hypothesis? An alternative hypothesis is the hypothesis that differs from the non-hypothesis stated by a researcher. As this implies, it is a hypothesis alternative to the non-hypothesis. The alternative hypothesis is usually denoted with H1 or HA. For example, H1 could be mu surface age is not equals to 25. That is, the population mean age of students is not equals to 25. Mind you, the non-hypothesis states the mean age, that is the population mean age of students is equal to 25 years. Since the alternative hypothesis is that hypothesis that is used to counter the non-hypothesis. So, the alternative hypothesis states that the population mean age of students is not equals to 25, or the population mean age is greater than 25, or the population mean age is less than 25. So any of these three would be the alternative hypothesis, as long as it is countering the non-hypothesis. And lastly, statistical decision rule. Statistical test decisions are made based on the result of statistical test. Any of the following can be used to make a decision whether to reject the non-hypothesis or not. 1. We can use probability value, that is p-value. We can use statistical test value, and we can also use confidence interval. So note that 1 to 3 here yield the same conclusion. Now, decision rule using p-value. In making a statistical decision concerning whether to reject the non-hypothesis or not, we compare the test p-value, that is the evidence in support of the non-hypothesis. P-value is the evidence in support of the non-hypothesis. And the chosen level of significance, that is the evidence against the non-hypothesis. If the p-value is equal to the chosen level of, if the p-value is equal to the chosen level of significance, that is, both evidences are equal, it is safer to reject the non-hypothesis. That is, if p-value is equal to the chosen level of significance, so we are going to reject the non-hypothesis. Now, but if the p-value is less than the chosen level of significance, that is, the evidence in support of the non-hypothesis is less, we reject the non-hypothesis. We reject the non-hypothesis. And lastly, if the p-value is greater than the chosen level of significance, in this case, the evidence in support of the non-hypothesis is greater, we do not reject the non-hypothesis. Now, the decision rule using a test value. In making a statistical decision concerning whether to reject the non-hypothesis or not, we can compare the statistical test value with the critical value based on the chosen level of significance obtained from the statistical table. The test value indicates the degree of evidence against the non-hypothesis, while the critical value indicates evidence in support of the non-hypothesis. If the test value is equal to the critical value, in this case both evidences are equal, again it is safer to reject the non-hypothesis. In other words, if our test value is equal to the critical value, we are going to reject the non-hypothesis. But if the test value is less than the critical value, in this case evidence against the non-hypothesis is less, we do not reject the non-hypothesis. And lastly, if the test value is greater than the critical value, the evidence against the non-hypothesis is greater, we reject the non-hypothesis. And lastly, decision rule using a confidence interval. In making a rational decision concerning whether to reject the non-hypothesis or not, we can check if the hypothesized value falls within or outside the estimated confidence interval. If the hypothesized value falls within the interval, do not reject the non-hypothesis. That is, there is greater evidence in support of the non-hypothesis. If the hypothesized value falls within the interval, then reject the non-hypothesis. In this case, there is less evidence in support of the non-hypothesis.